everyone, it's Wilmer from the Game Academy, and in this episode, let's tweak our visual effect graph with some Blackboard parameters. This is a continuation of our earlier videos on setting up our first visual effect graph, so if you haven't seen those already, check out the links in the description. Okay, so here's our basic VFX graph. Flaming tendrils, pretty neat, but in order to adjust the effect, we currently need to go directly into the graph and make changes. That may be fine sometimes, but it's not the most interactive way to get the look that we're going for. With the Blackboard in the visual effect graph, we can expose some of these input ports as parameters. Parameters allow you to make a slightly more user-friendly interface for input. Instead of digging through nodes and contexts and blocks, we can get some neat color chips, sliders, and fields in the inspector. Then you can make changes on the fly right in here. Whether you want to expose these parameters for yourself or just make it easier to collaborate with another game dev, setting up the Blackboard really takes no time at all. So let's do that for our example graph. And I'm using the one that we created in the last episode, but really you can apply this to any visual effect graph. Everywhere we have these input ports in the blocks, you can connect a node, as we've already seen. Instead of a regular node, we're going to create a special node called a parameter. And we'll do that by going to the Blackboard. Click the Blackboard toggle if the UI is hidden, and that's this button up here. Let's, for example, allow the user to set the number of particles spawned every second. First, we need to figure out what type of data we're looking for. The input ports are color-coded, and blue means it takes a single number, either an integer or a float. An integer probably makes more sense in this case. So let's create an integer on the Blackboard called number of particles. Click the plus icon, select int. That creates a parameter. Rename this to number of particles. Click exposed, so it'll show up in the inspector. Then give it a default value of, say, 10,000. Add a tooltip to tell the user what this specific parameter means. We'll write number of particles spawned per second. Pretty self-explanatory. Then drag the parameter icon from the Blackboard into the work area and connect the output port of the parameter node to the input port of the constant spawn rate. If you have auto-compile checked, then you can go straight away to the editor. Otherwise, manually click compile to save your graph. Find the VFX object in the hierarchy, and then take a look in the inspector. You should see a section entitled parameters at the bottom. And here is the number of particles parameter that we just created on the Blackboard. Hover over the label, and you'll see our tooltip. And you can interactively change this field, and you'll see the visual effect graph update in response. Drag this value so that the number of particles spawned each second is greater than or less than 10,000. Or you can just type directly in here. 100 particles, and you'll see our effect thin out pretty dramatically. Or 1,000 particles, that'll bring back some of the density. Here's 10,000, the way that we had it before. And at 100,000, our effect seems pretty dense and bright. You could dial it all the way up to 1,000,000, and maybe that's a little bit much, but my machine still can handle it pretty easily. Of course, we can always just back off from that. Not all values work for your parameter. If you want to limit what the user can type in the input field, we can go back to the Blackboard and check range. That sets up a minimum and a maximum for our parameter. Now, after testing, I think probably we don't want to let the number of particles spawned each second dip below 5,000. So let's set a minimum of 5,000 and let's max it out at 100,000. Make sure your default value stays around 10,000 or so. And you'll notice that we have a slider here now. Compile your effect and then go back to the inspector. We'll see a slider in our inspector as well. And we can use this to drop the number of particles down to 5,000 or increase it all the way up to 100,000. Of course, feel free to experiment and define a better range in the Blackboard that suits your purposes. But this is the general gist of setting up parameters. Pretty easy. What we want to do now is create more of them. Let me just set up a bunch of these parameters the same way. Now, when I'm done, I'll have a bunch of parameters for the lifetime min and max, plugging into the set lifetime random block, min and max. And I'll have another one called arc duration that controls how fast the effect revolves around the major ring of the torus. And then I'll have a couple of floats for particle size and particle width, and that lets you control how big the individual particles appear. Now I'm showing you my numbers only as an example. You'll need to do some trial and error and see what works best for you and your effect, of course. When we go back to the inspector, you may need to click the check button for on next to each parameter that we've created so that they're active. Unfortunately, when I do that, in this version of Unity, it overrides my default value with a 0, and that does look like a minor bug. Now we don't want our parameters to default to 0, so we'll need to plug in some values that make more sense in here. But the end result is that we have a bunch of sliders to play around with. And you can always just type directly in these fields if sliding the ranges is a little bit tricky to get the exact value that you're looking for. But very quickly, we can tweak our effect like so. Parameters can be more than just numbers. For example, currently the color of each particle is determined by the color alpha over lifetime gradient in the quad output. We can make a gradient parameter just as easily as we made an integer or a float parameter. And this will let us choose a gradient in the inspector. Click plus in the Blackboard, create a gradient. Let's call it color over lifetime. Make sure that it's exposed. I have a nice gradient already picked out from experimenting. I'll use that as my default. And this controls how the color and alpha appearance changes over the course of the particle's lifetime. So we'll make a tooltip that says that. Color and alpha changes over particle lifetime. Let's drag this icon into the work area and connect the output port to the gradient input. Compile and go back to the editor. Now in the inspector, unfortunately, the parameter does come in as off by default. You'll have to re-enable it. Our gradient gets overridden with a terrible black and white default gradient, but no matter, we can just load up a color gradient of our choosing. And let's hope that you can avoid this in whatever future version of Unity that you're following along with. Otherwise, just set the gradient again in here. Now with the color over lifetime, the effect looks quite a bit different. You can adjust the other sliders to complement our new color gradient. And you can make something like this, or just experiment and choose a whole new color over lifetime. Really, it's up to you. If you want to give your effect a little more variation, what we can do is change the color of each particle when it spawns. The color alpha gradient over life helps a lot, but we can add an extra pop of color with the set color block in the initialize context. Let me make a little bit of space up here, and I will add an extra block to the initialize context. Right click, create block, filter for color, and let's choose the block that's called set color. And let's shift these over so I have some room for some more nodes. And instead of just dropping in one color as a parameter, what we can do is sample a whole gradient of colors. Let's create a node and filter for gradient. And let's choose sample gradient. The sample gradient node lets you input a whole gradient of colors. That's this thing at the top. And then it outputs a single color. You can plug this output into the set color input. And the time slider determines which color to pick from the gradient. A value of 0 is the color all the way at the left. A value of 1 is the color all the way at the right. And everything in between samples the gradient in the middle accordingly. So I'll just drop in a gradient that I've already picked out. And then as I drag the time slider, you can see the set color block changes, sampling one color from the gradient. So how cool is that? Now to make this more useful, let's define another gradient parameter on the Blackboard. Click plus, choose gradient, and let's call this initial color cycle. Expose that in the inspector, of course, and then let's select our default gradient colors. Notice that this one is a variation of the gradient that I had in the color alpha over lifetime. It does have some HDR colors in it though, so the particles can glow super hot and intense when they spawn. So let's throw in an obligatory tooltip, range of initial colors for spawn particles. Drop this into the work area and connect that into the sample gradient, of course. Now the trick to making this work is to plug in a nice node operation into the time input. It's helpful to add a node that can cycle between 0 and 1. And that way, as the particles spawn, their initial color will be slightly different as the effect progresses. As we tick down the gradient, this will add a subtle variation in color glow to our particles. Each time new particles spawn in each frame, their initial color will be just slightly different than the particles in the last frame. So just slightly, and that'll make everything seem a little more alive. To accomplish this, I'll use a node that we used in the last lesson called periodic total time. That is a cyclical graph that looks like this. So if I create a node, periodic total time, connect this output to the time input. This function increments over time for a given range, which we can leave at 0 to 1. It starts at 0, gradually increments. When it hits 1, it cycles back to 0 and then repeats the cycle over and over again. Now, if you do this, it's helpful to choose a gradient which has the same color and alpha at the beginning and end. And that way, particles won't appear to shift abruptly in color when you hit 1 and then need to cycle back to 0. Now, how fast this node cycles is determined by the period up here in seconds, and we can let the user control how fast that is by exposing another parameter on the Blackboard. Click plus in the Blackboard. Let's make a float this time. Rename it to initial color cycle duration. I'll expose it in the inspector, and let's set our default value to about 5 or so. Our tooltip will say something like time to cycle between the initial range of colors or something like that. And let's drop this parameter into the work area. Connect the output to the period input of the periodic total time node. And then compile your shader and play around with some values in the inspector. Make sure your parameters are all active. Again, I'll need to reset some decent values in here. And sorry if that behavior is a little bit weird, but we can work around that. And now we can play with different gradients and values to make the effect our own. It oscillates between little pops of indigo and magenta, and it looks quite a bit different than the effect that we started with. Of course, feel free to tweak any of these controls to change the look. That's the whole point of this exercise, to make the effect easier for you to change. You can make the particles very fine and delicate, or big, bold, and bright. How you want the effect to look is really up to your application and how you want to use it in your game. Okay, cool. Well, that's all we have time for in this episode. As always, if you want to support the channel, like the video, subscribe for updates. If you want to enroll in our premium tutorials, check out the gameacademy.school website. Thanks again for watching, and I'll see you in the next video.